Hey everyone, welcome back to Elasticsearch webinar series. In last part, we discussed the usage of Elasticsearch as full-text search platform, which was the original goal of Shay Bannon when he started to write Elasticsearch. Today, we will take a closer look at second use case, the log centralization platform. Okay, now question is, why do we actually need to centralize logs? And what is wrong with tailing application log? Well, everybody wants to look like Link from Matrix movie, looking at characters pouring down the screen. But no, it's not cool anymore. And the reason why this so are multiple, but the most obvious one is if you have multiple instances of your application spread among number of nodes, you have to take a look at each node. Using some protocol to send new log lines into one place, you just need to look there. Other reason is security. Tailing application logs means logging into application server, and that is not something your security department will be happy from. Of course, that can be solved, for example, by network dry mounting to application server, but this also adds the level of complexity to your infrastructure. So we decide to send logs from each node of our application cluster to single file using, for example, syslog. If we are comfortable with grep, that might be sufficient, but why not to push our solution a few levels up? If we add Elasticsearch as the place where our logs are stored and indexed and Kibana UI, we can not only use full-text search over logs in a user-friendly interface, we also get the control over permissions for user, so someone only see a portion of logs. And if we leverage our logging so we send structured logs entries into Elasticsearch, we can visualize various statistics about our application. It sounds great, doesn't it? Now let's take a look at the whole ecosystem of Elasticsearch that we can use building such solution.
So we have a bunch of nodes with running applications. As first thing we need to start with is Elasticsearch, as this is the essential part for storing log messages. One important thing to mention, log centralization is a great example when to use hot-warm architecture of Elasticsearch cluster. In simple, we have few fast nodes equipped with a lot of memory and SSD disk called hot nodes. Then we have some cheaper, slower nodes that, for example, stores data only on rotating disks. These nodes are called warm nodes. Fresh log data that are accessed way more often than older data are stored on hot nodes. Then after defined time, let's say 14 days, the data are moved to warm nodes. And then after some time, you can whether delete old data or archive them. To implement hot warm architecture, all you need to do is distinguish your hot and warm nodes using node.attr.attribute name, for example, node type, followed by actual value. That is, for example, hot or warm. The setting is done in Elasticsearch YAML file on each node of your cluster. When we mark nodes of our cluster by their type, all we have to do is set node type requirement in our index settings, like this index.routing.allocation.require.node type, followed by required value, hot or warm. So most usually you will have index template which will contain node type requirement. So every new index matching given pattern will be allocated to required node type, most usually hot. Just be aware of your number of shards and number of replicas so that the cluster is able to allocate all requested shards and replicas to node of required type. Otherwise, your cluster might end up in non-green state. So now our indices are allocated to fast hot nodes. So we need to solve how to reallocate indices to warm nodes after a given number of days. We have three options. Use index lifecycle management, which is part of free basic tier of XPack. This option is highly recommended as you don't have to install and configure any other component. Every state transition is performed by Elasticsearch itself, and as a cherry on top of a cake, index lifecycle management has very nice UI in Kibana. Other option is using utility called curator, which run as a separate process and does all the work. And last option is to implement custom utility that will do desired actions regarding index management for us. We now know how to manage time-based data as log messages in Elasticsearch cluster. All we have to do now is to start filling logs in there. We have several options, but if we go the Elasticsearch standard way, we are going to use filebeats to grab new lines from log files and send them over the network, and optionally logstash to parse or enrich data. Back to filebeats and generally beats, Elastic itself calls them the lightweight data shippers, and that's practically what they do. They get the data, optionally perform some simple processing, and then ships them to Elastic or Logstash. So we will use them in our solution to get new additions into log files and send them to Elasticsearch. Example configuration of filebeat might look like you see on screen. The path property tells filebeats which files to scan. Multi-line properties are useful if your log files contains log messages spread to multiple lines. Then we have application property, which defines which application produced the log message. We use environment variable to set this property. And the last section defines where to send bulks of messages. In this case, we send them to logstash for additional processing. If your log files contains messages in JSON format and each line is separate JSON object, filebeat can directly parse a JSON. So if your logs looks like this, you can collect, parse, and ship them using just filebeats. And what about the logstash? Well, logstash is very useful if you need to transform or enrich your data. There are numerous processing filters, and in case none suit your use case, you can even write your own using a Ruby language. Logstash also offers variety of output plugins, so use case when you need to output some data to Elasticsearch and also to, for example, syslog is very simple to achieve. Since version 5.4, Logstash also offer feature called persistent queue, which, as the name suggests, is a queue that is persisted. So in case of high load in combination with slow outputs, data are still accepted by Logstash. They are stored in the persistent queue right after and processed later. You can see an example of Logstash configuration on screen. So it will ingest some data through Beats input plugin, then enrich data with GeoIP data from IP address field, and then output such enriched message to Elasticsearch. Now the data flows into Elasticsearch from log files read by filebeats, and optionally they are processed by Logstash. All we have to do now is to add index pattern into Kibana, and we are done. We have all log files accessible through Kibana, and when we also parse them into separate fields, we can make a lot of nice visualizations and statistics, like number of errors per hour, and also we have our data ready to be monitored by some monitoring and alerting tool.
And that's all from our log centralization solution. In next video, we take a look at the usage of Elasticsearch as monitoring platform, which is similar as today's topic, but we will add some new components like metric beat and APM agents. I hope you enjoyed log centralization the Elastic way, and see you soon. Have a nice day.